Hi, welcome to my channel. In the previous video, we discussed about the MNST dataset. MNST dataset. It contains 70,000 handwritten digits. Okay, handwritten digits, and it divided into two parts. One is 60,000 for the training dataset, and 10,000 images for the testing purpose. Okay, and now based on this data set, we are going to find out the two types of one classifier. That classifier is called a binary classifier. That means we are going to training a binary classifier on the training data set. So now we are going to perform this find out the performance of this binary classifier. In the previous video, we discussed about the measuring accuracy using the cross validation function. So in the find out the performance of any classifier, there are different ways are there. One way is cross validation. So compared to measuring the accuracy using cross validation, there are different types of performance metrics are there. In that, the one is the confused matrix. In this video, we are going to concentrate more on the meaning of confused matrix, how we are going to find out the confused matrix for the given data set. Okay. Now here the confused matrix, it is a better way to evaluate the performance of a classifier. We have to look into the confused matrix. Okay, now that means you have to find out the performance of any classifier, like it may be a KNN classifier, it may be a decision tree, whatever it may be. So for that we require some confused matrix. Okay, now the general idea is to count the number of instances of a class A are classified as a class B. So that means here actually the class labeled as a, but after performing the model, we are going to classify it as a B. So here the confused matrix shows that how many class labels of A are classified as a B in the form of one figure. Simply that is called as a confused matrix. For example, here we are having the one table is there. Okay, one matrix is there. That matrix is called as a confused matrix. Here and it contains two things are there. Okay, actually they are called as a actual class labels. Okay, here there are two types of class labels are there, negative or positive, and also we are going to have one more on the tables are there. One is on the predicted side, predicted class labels are negative and positive. So here what happened, this matrix is going to fill with four different types of values are there. Those are called as a true positive, true negative, false positive and false negative. That means here we are going to predict as a, in this column we are going to predict as a positive, the predict as a positive, and we are comparing the actual class label is P positive and predict also positive. That means both are positive. That means here we are going to place it as a TP. That means true positive. TP means true positive. The actual class label is P and predicted class label also P. That means both are P. We are predict as a class label as P, and we are comparing the actual class label as P and the predicted class label also P. That means true. So that is called as a true TP. That means true positive. And here we are predict as a, in this column we are predict as a negative. Here the actual class label is negative and the predicted class label also negative. That means both are the true. That means it is called as a true negative. TN means true negative. And here we are going to in this column here we are having the we are predict the value as a positive, but the actual class label is negative. That means here the actual class label is negative and predict value is P. That means both are false. That means false positive. FP means FP equal to false positive. And here we are going to the actual we are predict as a negative, but the actual class is a positive. So that means we are going that value is going to be false. The actual class is positive, but we predict as a negative. That means false negative. Okay, false negative, false negative. Like that, we are going to construct a one matrix for the given data set. Simply this type of thing is called as a confused matrix. Okay, now so here the two negative and true positive are always the correct predicted values. Both are the same values. Okay, now for example, here in our data set contains 60,000 images are there now. So for these images, we are having the different class labels like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 different types of class digits are there like 0, 1, 0 to 9. So the index of these are called as a actual values, and these are called as a predicted class labels. Okay, now so for example here, to know the number of times the classified confused image of class 5 with class 3. Now further we are going to see the actual class labels of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the index of the class labels, actual class labels, and these are the predicted class labels 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now here, for example, the actual class label is 5. Actual class label is 5. Okay, out of actual class label 5, suppose for example this is classified as a 173 times as a class label 3. So this is called as a the matrix shows the how many times the class label 5 is wrongly classified as a class label 3. So this by using this graph, this matrix, we are going to find out the how many times the actual class label is predicted as a wrongly classified as a other class label. Okay. Now for example here the initial class actual class label is 5, but we are predicted as a that is as a 3 class label. For that we are going to look into the sixth row. That means 1, 2, 3, 4, 5, sixth row and fourth column of the confused matrix. So this is the confused matrix 1, 0, 1, 2, 3, 4, fourth column. That means here 173 times the actual class label of 5 is wrongly classified as a your class label is 3. Okay, these are called as actual class labels, and these are called as a predicted class labels. Okay, now so based on this graph we are going to find out the how many times of the actual class labels are predicted as a wrongly classified. Okay, now to compute the confused matrix, first of all you have to need first you need a have a set of predictions so that they can be compared with the actual targets. Okay, now you need you could make a predictions on the test data. So remember that you want to use the test set only at the very end of your project. Once you have a classified, then that we are ready to launch the program. Okay, now instead of you can use the our model like cross underscore val underscore predictor function from the sklearn dot model selection import cross val underscore predictor y underscore train underscore predictor is equal to cross underscore val underscore predictor equal predict of stochastic gradient classifier. Further we are providing the x train data and y train data, and the corresponding cross validation equal to 3 folds. Okay, so just like the cross val underscore prediction score function, cross underscore val predict, there is a function that performs the k-fold cross validation, but instead of returning the evaluation scores, it returns the predictions made on the each test fold. Okay, that means in the previous class we are going to predict the evaluation scores by using the cross underscore val underscore score, but we are going to predict the predictions based on the cross underscore val underscore predict function. Okay, this means that you get a clean prediction for each instance in the training set. So that here the clean means that the predictions is made by a model that never saw the data during the training data set. Okay, now we are ready to get the confused matrix using the confused matrix function. We are going to use the one function is that function is called as a confused matrix. Based on the confused matrix, we are going to construct the confused matrix for the given training data set. Okay, just pass it to the target classes y underscore train underscore 5 and predict the class labels y underscore train underscore predict value. So from the sklearn matrix, importing the confused matrix. So the confused matrix there in the sklearn dot matrix. From that we are going to import the confused matrix. For the confused matrix, we are providing the y underscore train underscore 5. This is the actual training data, and this is called as a very predicted data. Okay. For that we are going to get the things from. So here these are called as a actual values, and these are called as a predicted values. Okay, already we saw what is the meaning of confused matrix. It contains okay, two things are there. One is two things are there, like actual class labels, and predicted class labels. Okay, and the actual class labels are nothing but a negative and positive, and negative and positive. Here true positive, true negative, false positive, false negative. Okay, now here these are called as a in our example data. It contains the class labels as a 5 and not 5, 5 and not 5. So for the in this here, the class label here for this data set, here the first row contains not 5 and second row contains class label 5, and the predicted class also not 5 and this is called as a 5 class digits. Okay, the total number of digits are 60,000 images are there. Among the 60,000 images, say 53,000 handwritten digits are belonging to our model is correctly classified as a not 5 class, and out of the all the actual 5 classes, 4,096 elements, 96 handwritten are correctly classified as a 5 of the actual 5 classes. Okay, now from this we are going to get the confused matrix. Okay, now here each row in the confused matrix represents the actual class labels. These are called as a actual class labels. Okay, and column represents the predicted class labels. And the first row of the matrix consists of the not 5 elements, and second row it contains 57 elements correctly classified as a not 5 and 5. Okay, 5, and that means they are called as a true negative. These are called as a true negative, and these are called okay, while the remaining are wrongly classified as a 5 class. Okay, these are called as a false positives, and the second row contains images of the this is the second row. This second row contains positive class, that is not 5 and 5. This is called as a positive, and negative not 5. These are called as a negative, and these are called as a positives. Okay, now the second row contains out of 1325 are wrongly classified as a not 5 classes. These are all these are belonging to 5 class labels, but our model is predicted as a not 5 class. Okay, that means these are called as a false negatives. Okay, while the remaining 4096 elements are correctly classified as a 5s. Okay, correctly classified as a 5. These are called as a true positive. Okay, these are called as a true negative, and these are called as a false positives. So like that we are going to find out our confused matrix. By seeing this one, we can say how many are correctly classified, okay, by our model. So a perfect classifier would have only true positives and true negatives. So we are considering only true positives and true negatives only. Okay, true positives and true negatives only. So its confused matrix would have non-zero values only on its main diagonal values. That means here the diagonal value shows the actual the true positive and true negative values, true negatives and true positive values always. Okay, and on the so always above the diagonal, below the diagonal must be 0. Okay, like that you have to develop your model. So in order to find out best model, y underscore train underscore perfect predictions equal to y underscore train underscore 5. We are going to give all the values as a y underscore train underscore 5. Predict the pretend the we reach the perfection. Okay, in order to provide the perfect model, we are going to assign all the values of the y underscore train underscore 5 to the y underscore train underscore perfect prediction. So okay, then we are going to once again find out the confused matrix y underscore train underscore 5 comma, these are called as a actual values and these are called as a predicted values, y underscore train underscore predictor underscore predictions. So here all are correctly classified as a negative not 5 classes, and all are here correctly classified as a 5 handwritten digits. Okay, so the confused matrix gives a lot of information, but sometimes we may prepare a more concise matrix like precision, recall, F1-Score, like that we are having the different performance metrics are there. In the next video, we are going to see them what is the meaning of how can you find out a precision, recall, F1-Score, okay, of the other different types of performance metrics. Okay, thank you for watching our video. Thank you.